Welcome back, algebrists. Today, again, just to stress, if somebody's following along in the book, we are going to look at 1.5, but what I'm going to call 1.5 is different than what your book calls 1.5. So, we're going to just look at 1.5 and we're going to review linear functions. And I'm just going to say linear equations. Our only focus today. So, if we're graphing a line, there's really one or two key characteristics that we're ever going to be after. Right off the bat, to graph these, except for the vertical line, straight up and down, they all have something that I saw people calculating on today's bell ringer. You were doing some ratio or a fraction. Slope. So, here we go. We're just going to have slope, and we're going to define it. Okay, what letter traditionally do we use to represent slope? M. Okay, what's slope? So rise over run is a good way to think about it. How else have you guys think about it? Or do you think about it? It's a kind of like a rate of change, right? So we'll just say this is simply, by definition, the ratio of what goes in the numerator? The change in something. The change in y in the numerator over the change in what? Okay, the change in x. Now, especially for today, not everybody's going to need to write down everything, and I totally get that. That is okay. But if you looked at the bell ringer today and you weren't sure at all what to do, I would probably write down everything. It is entirely up to you as long as you're writing something along the way. Okay, to find slope, you typically see it presented in a sequence or, a specific sequence. Right off the bat, I'm not going to use dashes because they look like minus symbols. When you first learn about slope, you use words. And I already heard somebody say this. It's rise over what? Over the run. Now, when you get to, I think, probably around 8th grade, you start to learn about some lovely Greek letters. And whether you even realized it was a Greek letter or not, doesn't matter. We use the word delta y, delta x. That all sounds familiar? How do I draw a delta? It's a triangle. Now, this is a capital delta in the Greek alphabet. Delta y over delta x. Now, delta shows up two classes really commonly, or two fields. It shows up in math all the time, but it also shows up in science, like all the time. What does delta represent? Say that again. I feel like I hear sounds, but I can't put a word to it. Change, there it is. So there's our change in y over change in x. What if I wanted to actually calculate it? So, really important here. Normally, we learn this as y sub 2 minus y sub 1 divided by, and here's a really important part, the order that I go in matters. Now, for the first one, it doesn't, and we'll see that in just a second. But the second that I commit to saying my second y value minus the first, what must match in the denominator? The second x value in this case, but yeah, absolutely, minus the first. Now, order absolutely matters once you've locked in your numerator. Could I have done y1 minus y2 though? Yeah, and just to make sure that we have it, y1 minus y2, that's allowed, so long as you do what in the denominator? x1 minus x2. These have to match. Okay. Should we do a quick example of finding a slope before we start talking about the actual equations? Okay, so no strong opinions there. What we'll do is we'll look at, bless you, we'll look at a few forms of these equations, and then we'll get our slope practice in there. Well, okay, so every line has a slope except this one, the vertical line. We'll talk about that in a little while. How do you write an equation of a line? There's a few different forms of it. Whose mind goes right to y equals mx plus b? Reasonable. What is that called? Slope intercept. So check it out. We'll go ahead and we'll knock out slope-intercept. Now, this is the form that everybody is most comfortable with by a long shot. Slope-intercept is the one that everybody's going to naturally think of when we talk about graphing a line. You guys have already told me it is y equals mx plus b. Now, all I care about within this is that we can very clearly identify why it's called slope-intercept and remember this formula as such. What is m? Hey, there's my slope. Okay, got it. What is b? The y value. What do you mean? The y-intercept. Now, just to be super duper clear, if I wanted to graph the y-intercept anywhere along the x-axis, what is the x value? Sorry, along the y-axis. It's always 0. So whatever this is, it'd be 0 comma b in this particular situation. Now, notice we have a slope and we have an intercept. It's that easy. Okay, let's knock out an example or two of these. Do I need to say anything more about this? X is our variable. So we have a function or an equation that if I want the y value to be output, this is my input. Okay, so here we go. Let's find equations. So find equation. Now I'm not going to specify. I'm looking for the equation in slope-intercept form based on the way that this example is going to be set up. So here we go. On A, I want us to pass through the ordered pair 0, -4, and I don't know, what's your favorite coordinate pair, Lily? That's not the origin. 3, 5. Okay. I'm sure I've asked questions like that. I know nobody really has a favorite ordered pair. When I'm asking that, I just want you to give me something to put on the board. Cool. All right. Well, I'm stuck. I have no idea what to do. What would you guys do? Oh, check it out. Liam noticed that this ordered pair right here, 0, -4, is the what value? This is the b, the y-intercept right off the bat. So check it out. I'm just going to note that. So I'll switch to green and I'll say, okay, b in this particular problem, I didn't tell you the y-intercept was this necessarily, but we can reason it out from here. B is -4. Boom, I got the intercept. I can write the equation, right? Not yet. Why not, Hawaii? Gosh darn it, I need the slope. Well, let's find it. I'm going to do some scratch work here. M equals, there is not a right or a wrong answer, depending on the order. King, do you want me to do 5 minus -4 for the change in y, or -4 minus 5? There's not a right answer. That is the one that I would have gone with as well. Cool. Why is this the nicer choice? We're going to add, is what's going to happen. Okay, the second I commit to 5 minus -4, what must match in the denominator? 3 minus 0. Okay, this changes to an add. It looks like you get 9 over 3. Does that simplify? 3? So, what? I think it's 3 over 1, right? So I will make this a note. We just found the slope is 3. Do I have the slope? Do I have the y-intercept? Can I write this equation then? Okay, we have not used this symbol yet. I will always advocate for the use of this symbol. These 3 dots, have we used in this class? Do you remember what it means? Therefore, I get to see. All right, that's all right. Therefore, check it out. Y is equal to, what should I plug in? 3 what? X plus 4 or minus 4? Minus 4. Okay, right now we are just finding the equations. We will look at graphing as well. How do you feel if I asked you to graph this function or this equation? Okay, so here's my challenge for you. I'm going to give you 60 seconds. Doesn't have to be perfect. I only realistically need like two numbers on your scale anywhere so that you can estimate your slope. I want you guys to produce rough sketches of the graph of this equation. Cool. 60 seconds starting now. Suggest I do here. Anybody else start with the y-intercept? Super easy, right? This is the way that I assume you've always done it. Here's -4. I plot it. Awesome. Good start, Chetty. How about number? She gone. King. If I have this, I've already knocked out the intercept. What's the only other thing I want to make sense of? Can you say that one more time, like twice as loud? The 0, 3. So you're talking about this thing? Okay, so my slope is 3, and I don't write it as a fraction, but was it a fraction? This is really 3 over what? 1. We don't normally write that down. This means that when I start here, how much do I rise? So 1, 2, 3, and then I run in the positive, since they're both positive, 1 over. Now, I can identify this point, and I can see that it's 1, -1, just from my scale. How many lines, or how many points do you need to draw a line? 2. Oop. And we have it. There is my lovely equation. I should have done this day one, and I'm terribly sorry that this wasn't the very first lesson that we had. That was a mistake on my part. Sorry. Hope you can forgive me, but we're getting it now. We'll be okay, I think. Should we do a slightly harder one? Okay. Together, like as a whole class, or you guys want to try one more with your neighbors and such? Okay, here's the deal. We do not need to graph this one. I'll put a graph up on the board that we'll think through. But again, graphing, super valuable. Don't get me wrong. There's like reasons to graph, but solving equations is not one of them. Okay, this time, using slope-intercept stuff, I want you to find me the equation through, let's say it's -3, 5. And, hey, that was coincidence. I don't know. Sonny, give me another ordered pair. Not the origin. 1, 1. You got it. All right. There's my challenge for you guys. I will give you another moment. If you have questions, can you talk with your neighbors? If your neighbors don't answer it clearly, can you talk with me? For sure. Do it to it. Here we are. This one, I saw a lot of people do this. Don't write this down. Why is this not right? Yeah, we only know it's the y-intercept if the x-coordinate is what? 0. That's a really easy trap to fall for. I wasn't trying to give you a trick question, but I want to make sure that if you made that mistake, if you want to identify b, it better be a 0 here. Has to be. Okay, so I don't have a way to get b right off the bat. What else do I need, though? So I need m. So here we are. Does it matter which way I go first? No. I'm going to do 1 minus 5. Now, my mind defaults to if I see two ordered pairs, and you don't have to write this, you can do it your own way, but this is what my mind defaults to. Like, every time I think this. So I'm always going to go this order unless I see something different. So I did 1 minus 5. What has to go in the denominator? 1 minus what? -3. So it's a plus, right? Okay, so let's see. I get -4 over 4, and that's -1. Okay, I got the slope. I'm feeling good about that. Here's where we see some differences. If I want to find b value now, Angel, we're going to do a different approach here, but I liked what you had to begin with. How do you guys find b? What? So I like, how many of you guys used y minus y1 equals other stuff? At least 2 people. Okay, if you didn't do that, my guess is you probably looked at your equation, and at this point we have y equals -x, and that's -1x, right? Plus b. Do I have somewhere given an x and a y that's on this line? You say no, Sonny. I have this one, and I have this one. I could choose either of these to plug in for x and y, right? Which one would you guys pick? Good choice. Could I pick this one? Yeah, why'd you pick that one? Smaller numbers, they're easier. So if we plug in 1 and 1 for x and y, we can solve to get our b value. So I'll make a little annotation here. Plugging in plug in the point 1 comma 1 for x and y, well, that would give us, whoa, super bold, 1 equals, and let's see, oh my goodness. So I'm going to plug in a 1 for each of these. I'm going to put it back in red just so we can see that substitution. Bless you. Everybody get this expression. 1 equals negative 1 plus b. Can we solve it for b? How? Okay, I'll add 1 to both sides of the equal sign. And I get 2 is equal to b. Cool. So now, notice we have m, we have b. Is that everything that I need? Yeah, I think so. I'll scroll. We'll just go over here. Therefore, what is the equation of this line? Y equals negative x plus 2. Now, when we graph it, and again, I'm not going to make you guys graph it right now unless you need the practice, because I think that you guys probably did a crazy amount of this in Algebra 1 and Geometry. I would plot the y-intercept. Here it is at 2. And what does the slope of negative 1 tell me to do?
1 letter.
Ooh, so I would always go vertical like y first. So 1 down. I'm fine with that. And right 1. What if I wanted to go up 1 first? Could I?
Yeah.
As long as I go up 1 and 1 left. Check it out. We have 3 collinear points that exist. Okay. Everybody seems to do it this way most of the time. Okay, I'm going to be honest. I would never in a million years do it this way. And there's a reason for that. Slope-intercept exists. Like, we get the right answer. You're good too. But give me another form of... Oh. Question mark? Okay, sorry. Here. Don't fall, don't fall, don't fall. Cool, is that better? Okay. All right. Well, we have slope-intercept. Easy, right? Slope and intercept. Give me another form of an equation. Y minus y1. Gosh, what is that? Ooh, say it again. Point slope. So check it out. We have a lovely form that if I give you the y-intercept, you can plug it in, and all you need is slope and the intercept. We also have point slope form. Now, this is going to be the way that I would default to writing an equation of a line every single time, because we can save a step of work in here. Okay, looking at this, we get the lovely equation y minus y1 is equal to m times the difference of x and x sub 1. Okay, people get goofed up with this equation. I'm going to put one little additional comment. What is the point that is on the graph? So I heard y1, that's part of it. x1 comma y1 is the point that's on the graph. Now, given a point, 2 points, this is what I'm always going to default to unless one of those points happens to be 0 comma something. Because in doing this, we don't have to do any extra steps to solve for b and plug it back in. Everything is just going to push right through, and at the end, with one single line of work, we're going to get the slope and the y-intercept together in the same equation. Cool. Does this form look familiar to everybody? Okay, let's do one. I want an example, and let's find one. So find equation, and these are all lines. That's our focus today. And then let's do our first one through. Ooh, should we get real crazy? Like fractions? Everybody wants fractions in your slopes and stuff? 2, -5. And Kyle, give me another ordered pair. That's not the origin. Ooh, gross. Love it. Okay. Now, my first line of thought, and my vocal is going to be really weird on this one. I need a lapel mic. Are either of these the y-intercepts? No. If they were, what would you see in the x-coordinate? 0. So neither of them are the x or the y-intercept, which means I know I can't jump right to slope-intercept. Which of these points is easier to work with, do you think? 2, -5. Now, that is subjective, right? Each person could choose a different one. But let's go ahead and knock this out. Step 1, I'm going to give you about 30 seconds. I want you guys to find my slope for me. Cool. Find me the slope between these two lines. I'm going to give you like a 10-second head start, and then I'm going to start calculating, and we'll verify we get the same thing. Don't just blindly trust my work, because I will be wrong. But I think I get 13/10. Okay, I'm going to resist the urge. I don't want to call it 1.3. You can, if you would rather, but I'd rather just keep it here. Okay, we have the slope. Whether I went, no matter the direction, doesn't matter, right? So all we need to do here is take this slope and pick one of these points. Can we all agree that this is going to be the easy point this time? Okay, so let's use this one. I'm just going to say easy, and hold on. Easy. Cool. All right. Let's use that point. And I'm going to plug it in for what? So really, really important. Y sub 1 and X sub 1. It has to be the subscript. We're not going to plug in for the other one. So here we go. We get Y minus, what was that X or Y value that we just said we were going to use? So Y minus -5 is equal to my lovely slope of 13/10. And must be X minus 2. Okay, here's where you're going to feel uncomfortable, I think. What did the directions tell us to do? Like, I only use 2 words. Find equation. Is there an equal sign? Do we have an equation? If all I say is find an equation, this is sufficient. This works. Now, naturally, you guys don't want to leave it here. You would all go 1 or 2 more lines of work and solve it for what? For y equals mx plus b. It's natural to want these things in slope-intercept. If you want to do that, I'm good with it, because a lot of the time I will ask for that. I'm going to solve this for y then. But I do want to be clear, this answer right now is okay. If all I say is find an equation. Cool. Well, how would you guys solve this for y? What's your first thing you would do, Mark?
Apply 13/10 to x.
So Mark said apply it. What's that property? We're going to distribute. So let's just see where it takes us. Y plus 5 equals 13/10x minus, this is 2/1, right? 13 times 2 is 26/10. Now, this kind of annoys me. Why? Because I can simplify it. Do you guys want to simplify it now, at the end? How would you do it in your notes? Or at the end? Okay, I disagree, but that's okay. So what's the next step? How do I get just y equals? So I'll subtract 5 from each side of this equation. And let's just see what shakes out. I don't know what purple I was using. 13/10 x minus 26/10 minus 5.
No. Common denominator.
Ooh, so I'll have to make a common denominator and such, right? Now, we're all at different points. Some of you in here, I imagine, can get the common denominator and stuff without showing any extra work. How do you write 5 such that it has a 10 in the denominator?
25.
So I'll knock this out. What do we want a 10 in the denominator, right? What am I allowed to multiply by that doesn't change it? 1. How many ways can I write 1? well, I could write it as a single 1 or a 2 over 2 or a 3 over 3. This is just my motivation to say, look, this is what we're really doing when we find the common denominator. This is going to be 50/10, right? Okay. So let's go one more step then. Y is equal to 13 over 10x. And then let's see, minus 26 minus 50 minus 76/10. 76/10. And could you stop here if you wanted? Yeah, we could simplify it more. Does it bother you guys if we don't simplify it? Me too. Y equals 13/10 x. What goes into 76 and 10? 2. 2 goes into this one 38 times. 2 goes into this one how many times? 5. And look at that. We have, in the end, a single example. Now, you may be looking at these and comparing the two previous examples and thinking, well, this method was not great. But I promise, if you would use these points and tried to do the exact same thing that we had on the previous problem, you would have ran through all the same gross math. You would have just had to go one more step to put it together into this form. Okay. How are we feeling about point slope? We should do one more maybe. Okay. Let's get one more. Today we're going to knock this out, and then tomorrow we're going to have a game of some sort. I don't know what the prize will be, but I got a bunch of whiteboards so that we can make sure we have this stuff locked in before we move forward. Did we? I don't know. Did we also have homework over the weekend? Good. All right. So on B, let's knock out through, let's say -2, 4, and I don't know, 10, 6. Okay. This I want you guys to work through. We'll see if we get the same answer right at the start of class. Your only job left for the remainder of class time is to get this one done, to help your neighbors if they need it. I'll come around and help as well. And then before you leave, please put your bell ringers. You can keep them in your notebook if you're okay. I'm going to grade them every Friday. But if you want to put them in that file folder that you made, you are welcome to do so. Cool. Okay, we'll pick up here tomorrow, but you guys have 2.5 minutes to finish this problem. In class anyway. Cool.